Hey farming fanatics and tech enthusiasts, let's kick things off with the big picture, precision agriculture. Forget the days of blanket spraying and guesswork. Precision ag is all about using data to tailor farming practices to each specific area of the field. Think of it as treating every plant individually, like a doctor fine-tuning treatment plans. We're talking about using real-time data from IoT sensors, drones equipped with high-resolution cameras, and even satellite imagery to get a detailed map of the environment. AI algorithms analyze this information, things like soil moisture, nutrient levels, pest infestations, and even anticipated weather patterns, to make informed decisions about everything from irrigation and fertilizer application to when to plant and harvest. Imagine maximizing yield while minimizing resource waste. This targeted approach is a game changer, especially for smaller farms in areas with limited water or other resources. This isn't just about efficiency. It's about farming smarter, not harder, which can boost productivity and lower environmental impact. Visuals, drone footage of fields, close-up shots of soil sensors, data visualizations on screens of AI systems overlaid on field imagery, charts showing yields before and after the application of precision ag techniques. Next up, let's talk about robotics and automation. The world is moving quickly toward automated farming. Imagine robots doing all the physical drudgery, from tilling and planting to harvesting and even weeding. These innovations aren't just about efficiency. They're about addressing the crippling agricultural labor shortages around the world while minimizing human time and effort. We're talking about autonomous tractors, robotic harvesters, and AI-powered weeding robots that use computer vision to precisely target weeds without harming crops. Visuals, robots planting seeds, a harvesting robot picking fruit in an orchard, FarmWise Titan weeding robot in action, a self-driving tractor plowing a field, various types of harvesting robots. These technologies free farmers up to focus on decision-making and strategy and planning, ensuring higher productivity and yield whilst optimizing resources. A significant challenge here revolves around the need for ongoing calibration and testing in real-world settings, ensuring that the systems are as effective and robust as expected. These innovations in autonomous vehicles are making substantial progress, with companies like John Deere rolling out fully autonomous tractors that could dramatically transform farming methods. Guys, crop diseases and pests are among agriculture's silent killers. Early detection is key to saving crops. Here's where AI comes in as a major force with computer vision. AI systems use the image processing technology to identify early signs of disease or pest damage, allowing farmers to intervene before things get completely out of control. Drones capture high-resolution imagery, transmitting data to cloud-based AI platforms. Similarly, smartphones can capture images for analysis through apps like Plantix, which can identify pests and diseases on crops accurately. This technology is democratizing access to expert knowledge, something that often affects farmers located in remote regions or in developing countries where support is scarce, and enables timely interventions, particularly in detecting small-scale infections. Early warnings of pest outbreaks enhance pesticide usage, cutting costs and reducing chemicals' environmental impact. Visuals, close-up shots of diseased plants, drone footage showing problem spots in fields, screenshots of smartphone apps diagnosing crop diseases and pests, charts showing the increase in yields resulting from early disease detection and treatment. Let's talk yield prediction. It's all about forecasting how much you'll harvest. Accurate predictions are indispensable for planning, logistics, and making savvy decisions about when to sell or store produce. AI improves these predictions immensely. Instead of historical or conventional methods, AI models integrate data from various sources such as weather forecasts, historical yield patterns, soil conditions, and even satellite imagery to paint a detailed picture of conditions and forecast crop yield. Using this sophisticated approach, farmers can make more informed decisions regarding planting schedules, resource allocation, and market strategies. This is particularly important for perishable produce. Visuals, charts showing yield forecasts, maps highlighting predicted planting times, data visualizations on screens of AI systems overlaid on field imagery, real-world examples of farmers using yield predictions. Water is life, especially for crops. Smart irrigation leverages AI technologies to optimize water use. Traditional irrigation often leads to waterlogging or unnecessary water consumption, given that it is not based on real-time data and analysis. In contrast, smart irrigation systems provide more precise scheduling tailored to the needs of crops. These systems integrate various data sources. This results in water conservation benefits whilst improving yields and crop health. Visuals, animations of smart irrigation systems delivering water, close-up shots of soil moisture sensors, data visualizations showing water usage before and after the implementation of smart irrigation, real-world examples of farms using smart irrigation. This approach is crucial in regions facing water scarcity, enabling farmers to sustain production amidst adverse circumstances. The efficiency of smart irrigation systems is often more pronounced in the case of farms where there is a consistent, stable water supply. Nevertheless, this technology represents a crucial stride that ensures the conservation of water to meet the future demands of increasing food demands. Now, let's talk about sustainability. AI is a tool enabling farmers to make choices that are kinder to the environment and ultimately sustainable. Precision agriculture, AI-powered pest detection, and optimized irrigation all help reduce the environmental impact of agriculture. Reducing chemical usage, water consumption, and waste contributes to more eco-friendly farming practices. For instance, the integration of AI-powered models in irrigation and fertilizers application can help save up to 20 to 30% water and 5 to 15% fertilizer respectively. The reduction of these inputs is not just about efficiency. It's about promoting sustainable agriculture, which is crucial given the need for more resilient food systems to cope with the global warming crisis. Incorporating AI applications into regenerative agriculture practices like crop rotation, cover cropping, and minimum tillage can drastically enhance ecological benefits by increasing soil health, carbon sequestration, and overall agricultural productivity. Visuals, images, or videos showcasing sustainable agricultural methods such as cover cropping and reduced tillage, charts illustrating lower water and fertilizer usage, reduced pesticide application, biodiversity increase, and higher yields in sustainable agriculture, graphs showing positive environmental impacts from AI-driven solutions and reduced carbon footprint. From farm to table, efficient supply chains are indispensable for food safety and security. AI can optimize every step, from predicting harvest times to streamlining logistics and transportation. AI systems analyze market trends, customer demand, and even historical production data to forecast future demands and plan planting/harvest strategies, eliminating waste, reducing spoilage, and minimizing financial risks. By streamlining logistics and transportation routes using real-time data, AI helps get products to their destinations quicker, ensuring that perishable goods arrive at markets fresh, and improve efficiency that can reduce fuel consumption, transportation, and packaging costs, thereby lowering carbon emissions. Visuals, data visualizations, and simulations showing supply chain optimization methods, maps illustrating optimized transportation routes, dashboards displaying inventory levels, charts showing reductions in food waste and associated costs, blockchain technology improving traceability. John Deere, a global leader in agricultural machinery, is at the forefront of the AI revolution in agriculture. Their AI-powered tractors, combines, and drones are equipped with advanced sensors and computer vision technologies that monitor various aspects of crop health and assist farmers implementing precision farming practices. These technologies not only optimize resource utilization, reducing water and chemical inputs, but also significantly augment productivity and yields. Deere's see and spray technology uses machine vision to precisely target weeds, which cuts down herbicide use while enhancing yields. Similarly, John Deere's autonomous tractors can perform various field tasks with minimal human involvement, streamlining operations and ensuring optimal crop management. Visuals, images of John Deere's AI-powered tractors and machinery, videos showcasing their autonomous and semi-autonomous features, real-world examples that demonstrate how Deere's technology enhances farms. Through innovative applications, John Deere is actively leading the agricultural tech revolution, establishing a blueprint for the industry by helping farmers tackle some of the most challenging problems faced in farming. IBM's Watson Decision Platform for Agriculture is a cloud-based AI platform that provides valuable agronomic insights to farmers globally. Through analysis of vast datasets, including weather patterns, soil conditions, and historical yield information, Watson can offer tailored recommendations that maximize yields while minimizing environmental impact. This platform supports many applications, such as selecting optimized planting times, monitoring for diseases or pests with an early warning, and fine-tuning for irrigation and fertilizer usage based on individual field-level requirements. By leveraging the power of IBM Watson, farmers can make sound decisions whilst optimizing their use of resources, cutting costs, and improving crop yields. Visuals, screenshots of the IBM Watson Decision Platform, examples of AI-generated insights for farmers, graphs showing increased yields and resource efficiency thanks to Watson, customer testimonials. Watson exemplifies AI's potential as a decision support tool that empowers farmers to make informed and data-driven decisions for a more successful and sustainable agricultural future. While AI is transforming agriculture, challenges persist. High initial investment costs, the need for robust digital infrastructures, training for tech adoption, concerns regarding data privacy and security, especially in developing countries with limited access to tools and technologies, along with the complexity of integrating AI with existing systems are some of the main obstacles to wider implementation. Nevertheless, some of these challenges can be addressed through a range of solutions. Government grants and incentives, partnerships between tech companies and farmers to enhance data sharing, and user-friendly interfaces and educational programs focusing on technical training and agricultural best practices are all needed. Visuals, charts showing investment in AI and agritech, maps illustrating digital infrastructure gaps, images showcasing training sessions for farmers, infographics summarizing data privacy concerns. As AI develops further, the combination of AI with blockchain, IoT, and quantum computing has the potential to unlock even greater strides toward a more intelligent and sustainable future for agriculture. Innovations such as digital twins might pave the way toward predictive maintenance, helping to reduce both costs and greenhouse gas emissions. The combination of these technologies has already improved yields, resource utilization, and agricultural output, and as AI continues to evolve, its impact will accelerate. This technological surge has the potential to fundamentally change how agriculture is organized. This should not just result in more food being produced and distributed efficiently, but also ensure that farms are more sustainable.